Hello and welcome to this Friday afternoon session. I'm going to call it an office hour again because the level of urgency has died down from some of those sessions earlier in January, so ending the month in a very different position than we started it, fortunately. And in keeping with that, because these are a little more routine again, I did want to once again begin mentioning that this channel is sponsored by Reask, a climate tech company that's helping to rethink extreme weather risk in a warming world. And of course, we've certainly been seeing that in spades all around the world in recent weeks. So again, continue to be grateful for Reask's sponsorship of the channel, and I do continue to work with them as a climate advisor and as a wildfire advisor. So as always, there'll be a link to Reask embedded at the end of the video. So today, I wanted to focus mainly on the now imminent atmospheric river, or rivers, I guess plural might be more appropriate, that will affect northern and central California over the next 7 to 10 days, and to a lesser extent now, it looks like also Southern California will get some additional precipitation from these. So that is generally good news, and I am working on a Weather West blog post that I will publish later today once I got to wrap that up once I finish this live stream and get through the meeting after. But I'll have that discussion to augment the live conversation here today. As always, there's a good opportunity to ask questions in the live chat that I will periodically answer, especially during the second half of the hour as those questions accumulate. But I do think it's worth overviewing sort of what we've experienced collectively in the past month in January in California. And it's been a remarkable month. It's been remarkable both for what happened in Southern California, of course, with the by record-breaking dry start to the season, and then the catastrophic wildfires that followed when that record dry air mass and vegetation coincided with an extreme downslope wind event, driving those two catastrophic fires well past the traditional wildland-urban interface in the San Gabriel Valley near Pasadena and Altadena, and then also along the Pacific coast, or Pacific coast adjacent parts of Pacific Palisades and portions of Malibu. Collectively, I think the toll is becoming a bit clearer. 29 deaths are directly attributed to these two fires together, and also nearly 19,000 structures having been damaged or destroyed. The significant majority of them are homes that housed tens of thousands of people collectively. So there's a lot of people displaced, a lot of destruction remaining, even though the fires are at this point, I think it's fair to call them essentially extinguished, even though containment might not be officially 100%. There has not been any active flame on these fires in quite some time, and there's not really any residual risk from the fires themselves. There may be some additional risk during the cleanup process from exposure to toxins, and then also potentially the ongoing risk of post-fire debris flows if and when heavy downpours do occur in and near the recently burned areas. So we'll continue to be talking about that the rest of the winter. And then, of course, there is the reality that there have been studies recently suggesting that the long-term effects of wildfires and other major large-scale disasters usually exacts a death toll that is anywhere from tens to hundreds of times larger than the official death toll through things like the long-term exposure to, in some cases, prolonged smoke episodes or residual toxins on the landscape, or even just the collective stress and anxiety of dealing with the disasters themselves. Of course, it's obvious that if you've lost your home or somebody that you know has lost their life, that's a pretty big deal. in your own life, but also even just the stress of evacuating for days or weeks on end, not knowing whether or if you'll be able to return, even if your home ultimately is fine physically. All of these things do extract a physiological and emotional toll, and I think we've now gotten better at quantifying what that means in the long run. It may not have as profound of an effect on everybody, and perhaps it doesn't even have a particularly large effect on every person in the disaster zone. But what is the reality is that when there are hundreds of thousands of people affected in these zones, even if the individual effect is fairly small, at a population level, it is actually very large, and we're realizing just how consequential these sorts of large-scale disasters can be in terms of affecting death rates and illness rates in the long run. And this is not anything new, by the way, and this is presumably how it's always been. It's just we're getting better at quantifying and recognizing that reality. So, although the immediate danger, I think, with the exception perhaps of future debris flows, has largely passed, the harm and the damage wrought certainly hasn't, and there's lots of thorny questions still being asked, appropriately so, I think, about how to proceed and what to do next and how to move forward. So that'll continue to be part of the conversation for a long time. So I just wanted to reflect on that a bit. I'll reflect a bit more of it on the post today, but primarily I do want to talk about the weather and the rain and the fact that we are not going to be talking about fire danger in really any part of California for a while, which is the good news. And in Northern California, we'll be talking about a bit of the opposite problem, some flood risk, although here too, I don't expect it to be particularly dire. And there are flood watches, in effect, from the National Weather Service for a good portion of Northern California, actually, for these upcoming relatively warm atmospheric rivers. So the snow levels will start low because the air mass is currently cold. They'll spike up to really high levels. So unfortunately, any of that early snow will be long since forgotten by tomorrow. And then the snow levels will fall again towards the end, but the bulk of the precipitation will fall as warm rain in the mountains. So this won't be a great snowpack accumulator, except maybe toward the very end of the storm. And we may even lose some net snowpack to start, but we are going to get a lot of water out of it, and that is the good news. The other good news is that because it has been super dry in Northern California the last 3 to 5 weeks, the reality is that there is less flood risk from what could be quite heavy rainfall in some of these places than there would have been had there been even an average amount of precipitation over the past few weeks, let alone wetter than average conditions. So we know that the antecedent soil conditions and the river levels matter a lot for whether a given atmospheric river sequence is likely to produce widespread or significant flooding. The good news is that this one does not appear likely to produce widespread or dangerous flooding because it just hasn't been that wet to begin with. And so this rain will be falling on relatively dry, not parched, but relatively dry for January or February soil. Anyway, in Northern California, the first couple inches will be largely absorbed by the soil. After that, it will start to run off. Rivers will rise. Some creeks may reach bankful or flood slightly, but just as there's a spectrum to wildfire ranging from, as we've seen recently, extremely catastrophic urban interface fires that harm a lot of people to highly beneficial fires that occur at whatever the beneficial or intrinsic frequency would be in a given ecosystem. Floods behave similarly, where there are big bad ones that are bad news for just about everybody and cause a lot of harm and destruction, but there are also lesser floods that actually help reinvigorate watersheds, flush sediment, flush pollutants, redistribute sediment into floodplains, and also serve as useful reminders that we do live in a world where floods can happen. So sometimes it's helpful to get that reminder in non-catastrophic forms. I think we're going to be more closer to the neutral side of the flood distribution in the next week or so. There is a risk of creek flooding, and obviously any flooding is dangerous if you put yourself in harm's way, but this doesn't look like an event that's going to be particularly dangerous for anybody who is not specifically entering river channels or deliberately going into harm's way. This is a case where it just doesn't look like there's a really high potential for serious flooding, even though there's a pretty high potential for minor stuff, street flooding, ponding, creeks reaching bankful, maybe very slightly exceeding them. But it doesn't look like there's going to be serious major flooding on creeks or widespread flooding of rivers, despite quite a lot of rain that's going to fall. Could that change? Well, it could change conceivably if the atmospheric river next week stalls out over one particular watershed, so this wouldn't be widespread, but there's always a potential you get a frontal wave or two that stalls out the atmospheric river over a relatively fast responding watershed, and that can always result in at least a slight chance of a more significant flood event locally. But this doesn't look like a huge deal, despite being a very large rain event. So just another illustration of how the antecedent conditions matter considerably when it comes to flood risk. And in Southern California, it does now look like the erstwhile second system in the bunch did evaporate and is not producing rain in Southern California right now or in recent days. I suspected that might be the case, but the good news is the next system now looks like pretty confidently it's going to bring at least some additional rain to Southern California. It could be a fair bit of rain if certain ensemble members are correct, or it could be just a little bit of light rain and drizzle if others are. I'll get into the details there later, but there is high confidence in a heavy to very heavy rainfall event across the northern third of California over the next week, and much less certainty about what will happen in Southern California, which ranges all the way from nearly dry to a rather significant rain event, which would produce some risk of debris flows in the fire zones. I would expect that the real world might end closer to the lower end of the spectrum, but even that still would result in some additional rain to keep the fire risk down once again in Southern California. So I don't think we really are going to have to worry about extreme fire weather conditions for at least, at a minimum, another couple weeks down south and for months as we go up north. I'm quite confident in that statement about Northern California. So I think it's worth sharing my screen. I'll do that now. There's a few things I want to share today, so let me just get to it. Oh, I see what happened. I have to adjust my screen here. I swear sometimes this magically readjusts itself without my say-so, but in any case, all right, just bear with me for a moment. I have to re-add the operating system screen capture. All right, so now you should be seeing my screen. I'll double check that that's actually the case. Okay, good. So the first thing I wanted to show is the Watch Duty app, and oh no, look at all this activity. Look at all these dozens of fires across the West. Well, look at what they actually are. For the most part, these are prescribed burns across really most of the West that you can see on this map. I mean, it's really, if you zoom out even further, there are a couple of legitimate wildfires, nothing huge, up in Montana, even in Idaho and New Mexico, where it's been relatively dry as of late, but the rest of these green RXs are prescribed fires. And as you can see, as I mentioned, zooming in on California, look how many there have been in Northern California in recent days. This doesn't necessarily mean that they're all actively burning right now. A lot of them, though, are trying to burn today right before the rain arrives, because you have to keep in mind, of course, that conditions favorable for prescribed burning, a lot of people are aware of the risks on the upper end. You don't want to really do prescribed fires under extremely hot, dry, windy conditions due to the downside risk of that prescribed burn escaping potentially and becoming an unwanted wildfire. But on the other hand, you also can't do much prescribed burning if it's pouring rain. Obviously, if you ever tried to start a campfire when it's soaking wet, it ain't gonna happen. So there is that Goldilocks zone. You do want to do it when it's somewhat dry, because you need to have enough combustion of that vegetation to really achieve your goals. And so that's exactly what we've seen with this very wet period in October through December in a lot of Northern California, giving way to an almost completely dry January, that actually is a pretty favorable precondition to do a lot of prescribed fire, because you have green up of grasses. So the seasonal grasses are green. I was in Sacramento and Yolo County earlier this week, and the green up has definitely begun, at least that far south. But with those dry conditions for about a month, the dead and down fuels, so those logs and twigs and branches and previous season grasses that are dormant, they did dry out a fair bit. And so you have this nice mix of green grass that has moisture that is drawing up from the soil, and some sufficiently dry material on the ground that is going to burn in a way that is useful and constructive. So it's been a really favorable period for prescribed fire, actually, over the past few weeks, continuing right up to the moment. And it looks like, based on all these updates from the last few hours, that there are a bunch of prescribed burners out there who are trying to get a bit more fire on the ground before the downpour pretty much puts an end to that for at least a couple more weeks. It'll just be too wet. It's going to be sopping wet, so not much potential for prescribed fire there. But I just wanted to emphasize again that there are no new, even in Southern California, no new and threatening fires at the moment, and I don't expect there to be at this point for the foreseeable future. So that is good news. So here's the satellite view of the western U.S. You can see right now there's a rather weak early portion of an atmospheric river draped across Northern California. If I switch over to radar, you can see nothing too impressive yet. There's some water falling. There's some pockets of trapped cold air, so there's lower snow levels. But this will become a much warmer but also heavier rain as we go into the weekend. And continue throughout much of next week. So nothing too impressive to show on the radar right now. But if I go back to the satellite and zoom out to continental scale, what you will see, and I may even want to zoom out a little bit farther. Here we go. So as has been noted by several folks, there has been some significant flooding in Hawaii, including on the island of Maui. So that's down here. These are the Hawaiian Islands. In recent days, with a Kona low, as it's known, you can see the convective showers and thunderstorms, even some supercellular thunderstorms and severe thunderstorms with water spouts in the vicinity. So that's sometimes a precursor to warm and wet atmospheric river conditions in California, and that is indeed exactly what we see with some subtropical moisture transport in this low pressure system here. So the atmospheric river having a pretty deep subtropical tap, drawing some moisture in, and then getting draped eastward sort of into California. So this system is not going to make it directly into California, but this long plume of moisture will in the coming days. So this is why the key word is going to be warm and wet rather than cold and wet for most of the coming week. So here's a depiction of where we are right now by the European model. Again, if I have to choose one, I usually choose this one because it typically is the single best model. It doesn't mean it's always right, but if I got to choose one for illustrative purposes, this is usually what I go. I'm stepping forward in time. Here's around sunset tonight. You can see the rain is kind of filling in across Northern California, and snow levels are rising, so warming temperatures. Nothing too dramatic, and there may even be a lull in the precipitation in the overnight and early morning hours before this atmospheric river continues for most of the day Saturday and becomes particularly heavy across the northern Sierra. And note, there's no rain, there's no snow anywhere depicted currently in the Sierra by tomorrow. This is 100% rain, except maybe up at like 11,000 feet. So it's, sorry to say, this is not going to be a skier's paradise type storm. In fact, this will be a very 21st century California atmospheric river, and that it's going to be quite warm, with rain all the way up to pass level and beyond in most places. And so that continues. In fact, it even shifts further northward. This is sort of classic behavior with an atmospheric river. As we go into Sunday morning, it shifts back northward. The atmospheric river retracts to the north. So places that were getting some rain down here earlier will then dry out again Sunday morning as the atmospheric river intensifies and lifts back further north. So this is known as essentially a frontal wave. So the warm, moist air coming up from down here and a system moving in from this direction, from west to east. So we see that get closer. We see this atmospheric river as we go through Sunday into Sunday evening stalled out in this region. So this is why the northern Sierra, from Mendocino into the northern Sierra, will be experiencing continuous heavy rainfall by this point. Now, there aren't very strong dynamics with the system up through this point through Sunday, so I would not expect this to be a very dramatic storm at sea level. In fact, this might be quite ho-hum in many ways in the Bay Area and the Sacramento Valley. This is a very strongly orographic, so meaning topography-driven rain event across much of California, and that remains so right up through about here. Late on Monday, the cold front begins to approach, and then it looks like the precipitation might be a bit more intense with some gustier winds as well as that pressure gradient strengthens. And you can actually see this is representative as these thickness lines go from warm to cold pretty quickly. That's a pretty decent front for California standards. So there will be a noticeable cold frontal passage. And look what else happens. Late Monday night into Tuesday, the snow starts to reappear in the Sierra. So again, at the tail end of that first storm, temperatures cool, and there will be a fair bit of snow accumulation. So snow levels crash, then even get relatively low, so below 4,000 feet probably by Wednesday. But by that point, the precipitation is mostly out of here. This is also where there's the most uncertainty about Southern California. So notice here, there's a surface low trying to spin up southwest of Southern California. Up till this point, this is Wednesday, Southern California remains completely dry. But as we get into late Tuesday into Wednesday, right now, the ECMWF, the European model, suggests that there could be a brief but relatively intense frontal passage in coastal Southern California. This could bring heavier rainfall to the transverse ranges and also some risk of debris flows. But that's a little bit speculative because not all the models and not all the model members agree that the system will hold it together that far to the south. So we'll just have to see what happens. I'll show a little bit more on that. Later in the week, though, a colder air mass is now across Northern California. In fact, you can see rather low snow levels across the northern and northeastern part of the state. And as we get Thursday, we're almost a week out now, but we're now talking about next Thursday again. A secondary system may come through and bring much lower snow levels and arguably quite a lot more snow, even though this is a much weaker storm than the much more robust but much warmer atmospheric river earlier in the week. And so after that, it's a little bit speculative. I won't go out any further with the deterministic model, but I'll switch back over to the ensemble. So again, here is the European ensemble, all of the model members averaged together. We can see this pattern as we go into Monday. Again, this subtropical ridging remaining across the desert southwest, but deep troughing across the Pacific Northwest. It's that contrast in between that's driving this persistent atmospheric river across the northern third of the state. That's very consistent with the pattern we saw earlier this winter with the dipole. Dry south, wet north, ridging down south, troughing up north, and an atmospheric river to split the difference. Well, that's kind of the pattern we're having again this week. It's just that fortunately it looks like there may be a brief interlude where one of these systems makes a pass on Southern California. And again, this is sort of illustrating on Wednesday the best chance for that to happen. Beyond that, there may be a drier period again as we go towards February 9th and 10th in California. Here again, there's a little bit more uncertainty what happens thereafter. This is an ambiguously wet pattern across California because what it says essentially is there'll be some troughing across the west, but it may not be far enough to the west to bring much rain or snow to California. In fact, it might be far enough east to bring more Santa Ana wind events rather than more rain events. So this is out towards mid-February. That's pretty far out still. So we'll see. Not a super clear signal. It's not a very strong signal either direction, but to the extent that there is a signal, we once again sort of get back to this general picture that we've had much of the winter and expect to have for most of the rest of the winter of stronger than usual subtropical ridging here and some troughing up here. If we look at the anomalousness or the unusualness of precipitation during this period, we see in the beginning, of course, we start out with way above average precipitation over the next week across Northern California. Rainfall of 5 to 10 inches above average, even in some pretty wet places. So that's a pretty conspicuous anomaly. But as we go forward into February, we see that there is, fortunately, a bit of a wet signal, by the way, down the central coast. That's a part of the state that could certainly need it. And although it's a mixed signal in Southern California, it certainly isn't aggressively dry to start out the month, which is good. But then as we go towards later in February, we once again see, in more places than not, a dry signal emerge again across Southern California, yes, but also Northern California. Not too worried about Northern California. In fact, it'll be good to get some drying in mid-February up there. Would be nice to see a more persistent wet spell in Southern California. I really don't see that right now still. But all in all, this is a relatively beneficial pattern compared to what we've seen recently. So overall, probably good news. What happens if I look at the American model ensemble instead? Well, again, very similar picture in the first week. Very wet in Northern California, not so impressive down south. As we get a little bit later into February, I think that that wet signal again fades in Northern California and a dry signal reemerges in Southern California. What's interesting is that the American model, and I'll show this now, is much drier for Los Angeles. For Los Angeles than the European ensemble. So here I have, again, this is a time series. If you go from left to right, this is going forward in time. So we're here at the beginning. Here's the 50 different ensemble members from the European model, each with its own time series prediction moving forward in time to the right here of precipitation. And you can see clearly in the European model, there's a very strong signal for a meaningful rain event in Southern California right around February 6th. In fact, the average is getting close to an inch of rain. So this would be, again, quite a respectable event. There's a few members where it's much wetter, see 3 inches. This would be a major debris flow risk type ensemble member scenario. But on the other hand, there's also a few members that are much drier. So for example, here we only get about 1/3 of an inch. This would be barely noticeable rain event, but the average is closer to 1/2 inch to an inch, and that's another pretty respectable rainfall. More importantly, I think every single member now, so 100% of members have some measurable rainfall in LA around the 6th. So this is very high confidence in a rain event of at least some magnitude, so that's the good news. There are some additional members that have some additional rain further out, so there's more uncertainty, as I mentioned, but the average is quite low, and there are many members that are completely dry after this storm is done. So we'll just have to see what happens. But again, this is the European model ensemble. If I choose a different model, if I go to the American model, I got to click through a few things here to show it, so just bear with me for a moment. I have to scroll back down to the same station here, and it's not exactly the same. But here's the same prediction from the American model ensemble, and it's actually a lot drier. In fact, there are some members that completely skip Southern California with this next storm. Right now, usually my default is when there's a difference to err in the direction of the European model. So actually, in this case, it's a bit of a bullish erring towards the wetter outcomes, but it is worth noting that the American model ensembles is a lot drier with this system, including some members that literally have 0 precipitation with it at all in the LA area. So a wide range of potential outcomes in Southern California, ranging from essentially no rainfall at all over the next week or so to rather significant rainfall, and I think that the latter is more likely than the former. In Northern California, though, it's completely different story. If I show the accumulated expected precipitation, and again, this is a slightly different map. This is not showing the instantaneous rainfall, but this is showing the total cumulative values across the whole period. So of course these values are larger. This is for point rays, so just to illustrate sort of the North Bay coastal perspective, showing a pretty solid 5 to 6 inches of rainfall cumulatively over the next 7 to 10 days. Nothing record-shattering by any means for February in this part of the state, but also a very respectable soaking, threading the needle between significant rainfall and really not that much risk of flood. Are there wetter members? Yes, there's some that double that, up to 10 inches or 11 inches. But there's also some members that are significantly drier, closer to 3 or 4 inches, although notably, Not a single European model member during this period brings less than about 4 inches of rain. So a very high confidence in a very solid soaking. If I move up the slope, this is for a point, again, same plot as previously, but for a different location in Northern California. Here, this is for Emigrant Gap, which is up in the Sierra Nevada. High confidence in an even wetter period. Again, here showing an ensemble average of about 12 to 14 inches of liquid equivalent. So on average, over a foot of rain or rain-snow liquid equivalent. Although I do think at this elevation, for better or for worse, most of it probably will be as rain. This could, of course, result in some flood concerns, and that's why the flood watches are in effect. But the good news is that rivers are running low, soil is starting out relatively dry, so the risk of widespread serious flooding, despite these bright purple colors, is generally low. Could there be an exception? Yes. Look at this ensemble member, for example, that generates not 10 to 12 inches of rain, but 27 inches of rain. That would cause much more significant flood problems. This is probably a member where one or more atmospheric rivers stalls over the watershed in this region. There's a couple of other members that do this. Here's 22 inches, for example. But there's also a few members that are drier than the average. Here's only, I say that tongue-in-cheek, 9 inches. And actually, that may be one of the lowest members. So high confidence that Emigrant Gap is going to get at least 10 inches of rain with a pretty wide upper tail up to 25 or 30 inches even, but that seems unlikely. The most likely outcome of 13 or 14 inches over this period would result in some flood risk, but nothing extraordinary. The very uppermost members, like this one, would result in considerably higher flood risk. And again, the odds are low, but not zero. If we count them up, there's 51 members here, so let's count the ones that are very high. There's 1, there's 2, there's 3. I'll count one of these as 4 and 5. So, 5 out of 50. So maybe a 10% chance of a more significant flood event. But right now, something more like a 90% chance of only mild flood risk from this. But again, illustrating that the risk isn't zero necessarily. And accordingly, as I mentioned, here's just the National Weather Service weather.gov page. The green area is the area outlined in flood risk, so that includes a lot of the Bay Area and the western slope of the Sierra. It's worth noting, again, this is not, I would not treat this flood watch as the same as some of the flood watches you've seen in recent winters. At this point, the flood risk is not nearly as serious as we've seen in storms in recent winters because the antecedent conditions are just too dry, and because right now it does not look like there's going to be an especially long sequence of stalled atmospheric or repeated atmospheric river storms. In fact, there's a clear drying signal about 10 days from now right now. If that changes, or if one of these atmospheric rivers stalls out somewhere in particular, that could change, but right now, that's what it looks like on my end. So I'm going to switch back over to stop sharing my screen. All right, folks, I do have a hard out at the top of the hour since I have another meeting sandwiched in here, and then I got to finish the blog post. So I will be officially ending this honor before the hour, whether I want to or not. All right, folks, going to take a look at the comments now. Thanks again for subscribing to the channel. We're now over 11,000 subscribers. That's a significant increase from December. It's helpful when people subscribe, and also separately if you sign up for notifications when I'm about to start a live stream. I know some folks have mentioned that they don't actually get notified even though they're subscribed and signed up for notifications. I'm not quite sure why that is, but that's unfortunately more of a YouTube troubleshooting issue. I can look into it a little bit more later when I have a bit more time. But thank you for the subscriptions. Again, it's free to do, so all you got to do is push the button. And thanks also for everyone's ongoing support in other tangible ways two, and one of those is by keeping the discussion in the comment section here and on Weather West focused and respectful. Although there's been a few exceptions, I'm actually very impressed overall by how that has maintained a reasonable balance, even in some, well, I think what's fair to say are pretty tumultuous times and some very stressful times, particularly for folks in California. All right, so some comments. Fascinating to see from Sandy, all the prescribed burns happening now north of San Jose all the way to Washington State. Indeed it is, and I am really glad that Watch Duty is able to showcase that. Both, I think it's useful for two distinct perspectives. One is from a anxiety reducing perspective. If you see a plume of smoke and you can go to Watch Duty and see that it's a prescribed fire, hopefully that greatly reduces people's concerns. And also, I think it is helpful just from an educational perspective to illustrate that there is prescribed burning going on with increasing frequency all around you, and hopefully it's something we continue to see more of opportunistically. And sometimes that is going to mean doing it in the middle of winter during dry spells like we have seen in Northern California in recent weeks. All right. There's a few folks who've asked what I was doing in Yolo County. I'm in Northern California with some regularity. Again, my new role is primarily with University of California Agriculture and Natural Resources, which is based in Davis. I was visiting folks in the office there, doing some administrative work, and I also gave a keynote talk at the California Irrigation Association meeting earlier in the week in Sacramento. So getting to know Midtown Sacramento a bit better as well these days. But I'm pretty frequently along, I often refer to the Interstate 80 corridor from a meteorological perspective as a bit of a dividing line between a lot of the storms that we see. It's also a corridor that I'm physically present along in some form or another with some regularity from San Francisco up into the Sierra foothills. The comment that the Weather Service of Sacramento raised the flood watch, the elevation of it to 6,000 feet, and the Yuba River along 80 and the American River along Highway 50 will be flowing high, no doubt about that. Doesn't, again, at this point look like a hugely dangerous flood event, but again, fast-flowing rivers can be dangerous if you're not careful, and there probably will be some flooding of small creeks and streams and roadways, so that can certainly be a nuisance, and it can be dangerous in some contexts as well. And there's at least a slight chance, a 5 or 10% chance, that we could see a stalled AR bring a more significant flood event to some watershed. There's a comment. There's a comment from Zepp about the thoughts on the sudden releases on the Success and Kauai. So it's not fully understood exactly what happened earlier this week down in Central California. So on these watersheds that eventually drain into the Tulare or San Joaquin basins. This is actually a story that was broken by the San Joaquin Water News, and not totally clear on what happened, but the Army Corps of Engineers, so again, this is a federal entity that is under the auspices of the current presidential administration, ordered a sudden, large, and unannounced release of water from reservoirs that was highly alarming to folks downstream because there was no pre-notification, nor was there any indication that there was an emergency need to do so from a flood protection purpose. In fact, there was subsequent concern then that the release itself might have caught people unaware who were actually still in the river channel, because normally there is a much lower flow, base flow, unless there are pre-storm flood releases. To me, at this point, I'm not sure what happened. It sounds like there may have been some political interference in a way that could have been quite dangerous. Fortunately, it appears that the Army Corps, at the last minute, partially backed down. They still released water unexpectedly and at a pretty high volume, but not at the extremely high volume that had been initially ordered. I think this might actually be related to some false statements that were made earlier in the week about the Army coming to California and, quote, releasing the water. In retrospect, this is probably what was meant by that. It was chaotic. A lot of people are very upset, including farmers and water rights holders in the San Joaquin Valley, emergency managers, and pretty much everybody who lives in the system. So I don't have more information. I'm just going based on what's publicly available. It's an emerging story. But I will say that while it remains speculative, if there really was truly political interference in this water release, which, had it occurred as originally planned, could have been quite dangerous and arguably reckless, that is not a good sign regarding the way in which that power, and it is power, will be wielded moving forward from a flood control, a dam safety, levee safety, and a drought risk management perspective. At a bare minimum, full notification, advance notification of the folks who will be affected downstream is absolutely critical. But really, more than that, it's really important that this water be managed in ways that is in the interest of safety and long-term drought resilience. So I hope that continues to be a focus. It appears that it probably wasn't the primary reason in mind when these releases occurred. So right now, that's all I can really say without further information. But I was very surprised to see this, as was apparently everybody else involved locally and regionally. To our knowledge, that has not happened before in this setting. So a question from Thor. Are there any regions or conditions where you'd pick the American model over the European model? You know, it's really only a modest edge. On average, the European model is better than the American model, maybe like 55 to 65% of the time. So if there's no compelling reason to pick one over the other, that is why I would go with the European model. But they're still comparable. And sometimes, 45% of the time, the American model ends up being more correct than the European model. So it's just kind of a law of large numbers, long run average type strategy. It's mostly just in the absence of some really compelling information to pick one over the other. My personal default is now the ECMWF, but it's not always the case. So there's a comment that the National Weather Service in Sacramento has an earlier video mentioning a bit of rain shadowing going on in the valley today, presumably the Central Valley. You talk more about the rain shadow effect. So we are definitely seeing major rain shadowing today, and I expect to see it actually for most of the duration of this event, right up until the final cold front at the end, where everybody should get pretty wet in Northern California. And this is something we commonly see with what I would call weakly forced atmospheric rivers. It doesn't necessarily mean that the atmospheric river is weak. In fact, this one will be probably category 3 or 4 out of 5. So that's a strong atmospheric river. But the atmospheric river scale only measures the amount of water flux in the column of air above your head. So if you think about a cube of air or a square of air in a two-dimensional sense, how much water vapor is being moved through that square over or a rectangle, really, a large skinny vertical rectangle per unit time. In this case, it's a heck of a lot of water vapor because this is a strong wind aloft situation and a very copious subtropical moisture tap system. So there's a lot of moisture getting fluxed in the air above your head. But just having moisture in the air, or even a cloud, as you know, is not enough to produce precipitation. You need some mechanism to cool and condense that vapor further into raindrops or snow that becomes rain later as it melts. And there's a few different mechanisms to do that. So essentially what you need is upward vertical motion in the atmosphere as well as moisture. If there's enough moisture and enough upward vertical motion, you get rain. Low pressure systems can generate their own upward vertical motion on their own by virtue of the vertical circulation of air as it converges near the surface of the Earth and then rises near the center of a low pressure system, because a low pressure system creates a bit of a vacuum. Air flows in to meet it close to the surface, and then for conservation of mass reasons, it's got to go somewhere. The wind can't blow into the ground, so it gets forced upward. You have upward vertical motion associated with stronger low pressure systems. There are other processes like frontal lifting. So if you have a cold air mass that wedges in under a warm air mass if you have a mixing of air masses of different density in some form or another, so either different density because of thermal changes, so one air mass is warmer than the other, or differences in density because of moisture differences. This is actually known as the dry line in the Great Plains in Texas during tornado season. It's another sort of pseudo front. It's a moisture boundary. You can get differences in buoyancy in the atmosphere, and that can cause the air to rise as well. So you can cause what's known as frontal lifting. But there's another type, and that is essentially associated with what's known as orographic lifting, or lifting induced by the mountains themselves. And if you have, using my post-its here as a visual aid, if you have a mountain range, and you have air flowing to the mountain range like this, so imagine this is the Pacific side of the mountain range. Say this is the Sierra Nevada. You have air that's flowing in from this direction, and it can't go through the mountain, so it's got to go up and over the mountain. As that air is forced upward, it essentially it expands because the pressure at higher altitudes is lower. It therefore cools. Think about decompressing a bicycle pump. This is actually the opposite, by the way, of what happened during the LA fires, where it compressed and warmed as it came down. Well, if it goes up, it's going to cool, and if the air is moist enough, it's going to condense as it goes up. So as that happens on the mountain slope, even if the air is kind of neutral, not really rising or falling out here, it's definitely going to rise as it goes up over the mountain. And that's going to produce what's known as orographic lifting, cooling, condensation, upward vertical motion induced by the mountain itself, and therefore precipitation that falls. So the rain shadow then occurs on the opposite side of the mountain. So on this side you have orographic precipitation enhancement. So this is the coast side of the coastal mountains, the western slopes of the Sierra Nevada. But on the other side, you have the air descending and again compressing, warming. So now you have downward vertical motion, that is precipitation and cloud suppressing, plus you've extracted some of the moisture on the windward slope of the mountain over here. So not only is the air now descending, drying and warming on the leeward side, but there's also less moisture in it to begin with. And this is where the rain shadow will occur. It's on the lee side of the mountain slopes and in the subsequent valley. So we see that on the western side of the Sacramento Valley in cases like this. And also, this is why the valleys east of the Sierra Nevada in the Great Basin are so dang dry, is that the Sierra Nevada is a pretty large mountain range that's very effective at first squeezing out what remaining moisture there is, and then inducing pretty strong downward motion on the lee slopes. That's why if you want a big snowfall on the eastern slopes of the Sierra, it's usually not the big wet Pacific storms that produce them. It's the more unusual low-pressure systems over the Great Basin that make the eastern slopes from the opposite direction the upslope direction, which is somewhat unusual. All right, well, since I do have another meeting coming up, and I do want to wrap up the blog post that I'm currently writing for today, I might end this session for now. So thanks all for joining. But I did want to again thank Reask for their sponsorship of the channel, and as always, I'll include a link to their website embedded at the end of this conversation, which as always will be recorded and available shortly after I push the stop button for folks to view in perpetuity and asynchronously once we're done recording live. So thank you. I'll be back next week, and in about 1 to 2 hours, do check out the Weather West blog for a new update on the current atmospheric river pattern and much lower fire risk pattern, arguably close to zero fire risk pattern over the next couple of weeks. See you next time.